Hi friends, hope you all are doing well. This is our fifth part of CISA video session. Today we will discuss on data types, specifically value type. So let's start. What is data type first? It defines the type of data or information we want to store in our variables. So in our last example or in our last class, we have learned on variables. So let's create another class for data types. Data types example class, and here we will define our main method. Public static and to make it as a startup project, let's click on this properties, then startup object, then our data type example class. So now the application is ready. Now last time when we learned about our variable, so how we declared int I is equal to 10. So I already told you like int is our data type. So what does it means? It defines the type of data or information we want to store in our variable. So the variable is here I, which is a type of integer, or it will store a type of integer. And what is this integer? And all we will now discuss. Or we can say the kind of data a variable can hold. So what type of data this I can hold, this will decided by this int. So this is a integer type of data. Categories of data types, how much space it occupies in our memory, that also depends on our data types. So data types not only decided the type of data but also decided how much memory spaces it will occupies in our memory. That also depends on our data types. Category of data types, one is value types and another one is reference type. So today we only discuss on value types. Value types holds their data directly in memory. So in memory, if you say value type, it will directly store the data. Like if I equal to 10, then this 10 will be stored in our memory. Whenever we will learn about or we will discuss on reference type, at that time I will tell you what that reference type stores in the memory. But in case of value type, the direct value will be stored in our memory. This is value type. So some common value types, one is integral types. Inside integral types there is different data types as well: int, short, long, byte. These four are called integral types. So what is this int first? Represent a 32-bit or 4 bytes signed integer. What is signed integer first? Signed integer can represent both positive and negative numbers. Both plus and minus, positive and negative numbers can store by signed integer, including 0. So integer is nothing but a 32-bit 4 bytes signed integer. It will represent a 32-bit signed integer. Range is like this. So from this value to this value, integer can store the value. Purpose is integer type most commonly used. General purpose integer type. So we are commonly, whenever there is a number we want to store in our memory, that time we use this int. Example, int age is equal to 30, int population is like this. This would be too large for int, so we use long. So whenever we use long, then we will discuss on this. But in normal case we are assigning the value to a integer data type. Let's assign this value int age, int population. Let's say, if you see, this will throwing an error, cannot implicitly convert type long to int, because this will exceeding the range of this integer. Integer is, the range is between this to this, so this is more than this range, that's why it is not capable of storing this value, this 7 8 whatever the value, it is long for, or it is out of like range for integer. So integer can store up to this range. Okay, got it? Till this it can store. Let's assign this value by removing this commas. Yeah, it can store till this. If I will assign 8, it will throw an error saying it is a uint to int, so cannot implicitly convert type u into int, so it is the not in the range of integer type. That is our integer type. To store normal values, to store normal numbers. Then sort. What is sort? Represent a 16-bit 2 bytes signed integer. It is signed integer, it is also signed integer, so the range is from this to this. So this is sort, means if the range is less than this integer, it can store up to 32,076 for smaller numerical values where memory efficiency is a priority. So whenever there is a small number or some small numerical values, at that time we can use sort. Let's copy these lines and let's remove these lines as well. See, we can store -10, we can store 300 in our sort data type. So if we will assign till 767, 32,767, that will be fine. More than this, it will throw an error. That is the range of our sort data type. But all int sort are used to store number values. Then long. What is long? 64-bit 8 by 8 bytes signed integer. This is also signed integer, can store both my negative and positive value, and the range is bit high as compared to int and sort. You can see this is the range. So for very large number exceeding the range of int. So whenever the int cannot store that like long value, that time we can use long. You can copy this and paste it here. So, and the prefix will be, sorry, the postfix will be L. So at the end we need to add this L to represent a long integer or a long number. Byte represents an 8-bit or 1 byte unsigned integer. All these above data types are signed integer, but this byte is unsigned integer. What does it mean? Unsigned means integer can only represent non-negative numbers, positive numbers and 0. It cannot store negative numbers, only 0 to 255. For small non-negative values with a limited range used to save memory, like this. Byte label may be 255. Okay, 256 it cannot be stored. So the range is till 255 and it cannot store negative numbers like short, int, long. It cannot store minus values because it is a unsigned integer. It is a unsigned integer. So whatever we have discussed like int, short, long, byte, all are representing a number values with some ranges, like there are some specific range for each of this data type, but every data types or each of these data types are used for storing integer value with different range and different size. As per our requirement, we can use long, byte, int and short. And clear about this signed integer as well. The second one is after this, what is this integral types. The second one is floating point types. So what is floating point types? Which is used to represent some point values or some decimal values. So floating point is of like three types: float, double and decimal. These are the size, these are what is single precision and double precision. I'll show you. When we talk about approximately seven significant decimal digit in the context of float in C sharp, it means that a float can accurately represent number with about 7 meaningful digits. So if you see, float is single precision, means approximately 7 significant decimal digits it can store. The precision is 7 significant decimal digits, not more than that. You can see, if we will see, float can store up to, in you can see this example, 1 2 3 4 5 6 7. So we already seen like it is 7 significant decimal digit. So this is up to 7, and after that it will representing 8 and 9 after point. So totally there is 9 significant digits, but it is out of range for float. So due to the limitation of float, which can accurately represent only about 7 significant digit, the representation of the number may be rounded as seen in the output. So we can copy this example. Let's say we are declaring float number, one number, and this is 1 2 3 4 5 6 7.89 f. F is representing float. So after the number, you need to use this f to represent a float number. So whenever we will print this float number, so let's see what is the output here. See, 1 2 3 4 5 6 7.9. So 9 is coming. It is rounded up the value after this point, because 8 9 is not accurately showing as the float. This number exceeds the precision point of the float type. You can see that is float. So it can like represent only 7 significant decimal digit. More than that, it will round up that value. Rounding or precision loss. Okay. Next is our double. Double is also, it is single precision, it is double precision. The size is 64 bits and the precision approximately 15 to 16 significant decimal digits. So whereas float can store approximately 7 significant decimal digit, then in the case of double, it can store up to 15 to 16 significant decimal digit. The range is like this. And for double, we can use d or d as suffix, as double is the default for floating point data, used to most floating point calculation, providing a good balance between range and precision. So as per our requirement, like we want to store 8 bytes of data or 64 bits of data, then we can use double. Then whenever there is a requirement of smaller than this double value, then we can use this 32 bits or 4 bytes float data type. And there is another what is data type, floating point data type, that is decimal. It will represent 128 bits or 16 bytes of size. Precision is 28 to 29. It is a large like precision data types where the suffix can be used m or m. Ideal for financial and monetary calculation, where high precision and exact decimal representation are crucial. Other data types, whenever there is like the, it will, when the precision will exceeds, it will rounds up the value for a float and double. But in case of decimal, the as the range is very large or long, and the significant decimal digit also long, like the precision is also bigger, so we can use for calculation. So it will not round up any values, we can get a exact calculation of the like financial or monetary calculation. So we have already discussed this single precision as well as double precision. If you see example of floating point types, let's copy all these and see what is the difference. So I am declaring three variables. One is float, one is double, and one is decimal. Float value, double value, decimal value. Here we want to store this one by the suffix f. This one where double d is like optional, and for decimal m is also required as a suffix. But you can see the difference between the size or the precision, and we are printing this float value, double value, decimal value. Let's see if it will print the exact value or it is missing something. See, it is only 1, 2, 3, 4, 5, 6, 7. After that, it's rounding the value. Till this, it will show correct only. After 7 precision or 7 points, like from 1, 2, 3, 4, 5, 6, 7, till this 2, it will show the exact value. Float, okay, float value 3.145592. Okay, till this 592, it will show the exact value. After that, from this 6, it will rounding that value to 7. And for double value, whatever the range, till that point, it will show the exact value. After that, it will rounding the value. Let's see. We will till 793 as double. What is the precision of double? Double precision is 15 to 16. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So till 14 or 15. Till this, it will show the exact value 793. After that, it will erasing that value, or it is not receiving that value, or it will not showing that value. And for decimal, it will show all that value till 32, because it is larger in precision. So we can understand, like whenever there is a requirement to store a small value, we can use float. More than for like the size in float, we can use double. And if it is a bigger than like bigger value as compared to these two, we can use this decimal values. Same for int, short, long, byte as well. So whenever there is a small value, we can use byte, then int, short as well, and there is a, if there the value is long, then we can use long. There is two more data types left in our value type. What is that? Other value types, char and bool. What is this char? Represent a single 16-bit Unicode character. So char is a 16-bit or 2 bytes data type. Range, it can represent any Unicode character used for storing individual characters. Character literals are enclosed in single quotes. So let's declare a char value as well. char. Let's say c. Char c is equal to a. So for like a single value, single character, individual character such as a or 1, in that case you use char, because it cannot take more than one value, it will throw an error. You can see too many characters in a character literal. So only one character we can store in a char value. and it will always enclose with our single quotes. Okay, and another one is bool. Bool only bool B equal to either true or bool, let's say D, false. So bool can only store true and false. Represent boolean value true or false. We can use in conditional statement whenever we'll discuss if, else, while, do, while, for loop, logical operator. At that time, bool type will be required. So what is the example for bool? If bool is running true, if it is running, then take an umbrella. Else, no need for an umbrella. Whenever we'll discuss on this if else condition, that time we'll discuss like how a bool is going to be used in our if else. So bool is basically used for to store two values. Bool B, bool B is true, bool D is false. So only true and false can be stored in bool. Character can store a single character. Float double decimal can store floating points values, and int short long byte can store integer or number types value. And this first three can store like positive and negative numbers as well, but byte only can store positive numbers, it cannot store negative values. Got it? And as per our requirement, like if the value is long or the precision is long or the size is long, we can use decimal, double. Here in case of integer also, so long. Whenever there is a small precision or smaller than this long values, we can use the, as per our requirement, we will use this data type. So this is all about our value type. In the next video, we will discuss on reference type. Data type can be of two types we already discussed. Today we have already discussed value type. In our next video, we will discuss on reference type. That's all for today's session. Thank you for watching. If you found this video helpful, please consider liking, subscribing and leaving a comment. Your support and feedback are greatly appreciated.